Assalamu alaikum. First of all, I'm very much thankful for the faculty of Narowal University, UT Texla campus for inviting me on the seminar on artificial intelligence and multidisciplinary research. I'm really thankful for the chair of this seminar and the faculty members who are in contact with me from the last couple of months to organize this session. And I wish in the next time I will be physically present in that campus and try to learn from you. So for my today's topic, for this artificial intelligence and multidisciplinary research, I'm going to present the results of my ongoing current research project, which is about the state of the art techniques for structural health monitoring of structures. Let me introduce my research group. So I'm the PI, principal investigator of this project. I'm currently working as associate professor at Department of Civil Engineering. My co-PI is Dr. Junaid Mir. He's assistant professor at Department of Electrical Engineer. And my international collaborator, Professor Charlie Scam, he's currently a professor at Department of Civil Engineering of University of Memphis, Tennessee, USA. We are really thankful for the Punjab Higher Education Commission for awarding this project in 2021. We are among the 25 awardees out of 500 applications. It's a brief introduction about myself. I have experience of more than 14 years of research, teaching, and professional experience. Currently, I'm working as associate professor. I graduated at UTexla. I graduated from UTexla in 2008. Then I got a Pakistan Engineering Council merit scholarship for my master's studies. In 2014, I got GEM-Wet Scholar for PhD, fully funded scholarship from Heritage University. And inshallah, next month, I'm going to join University of Memphis as a Fulbright scholar for postdoc position. Currently, my citation I have 85 publications, conference and journal publications with a citation of 510 plus citations, and the H index is 12. I'm also, beside the authors and a teacher, I'm also an academic editor of the Advances in Civil Engineering, having impact factor of 1.9, and Material Problems in Engineering, having the impact factor of 1.6. So let's start. What the meaning of the structural monitoring and how can we assess this? Like a human body, as we are getting old and old, we need medical checkups, the blood tests, the sugars, the PPs, and then against our disease, the doctor recommended some medicines. In a similar manner, structure damage is an intrinsic property of the civil engineering structures, which depends upon the time. As the structure getting old, it has some external actions in a form of earthquake, wind, explosions, temperature variations, and due to these actions, the structure shows some reactions. Unfortunately, in the last month, we had witnessed the severe earthquake in Turkey and Syria, which caused more than 40,000 human losses, and the infrastructures, the development. So we can well imagine that how these actions will impact. Now, what are their reactions? So we have some short-term and the long-term damages reactions of these external agents. Sometimes we have a very minor cracks of on structures, and we named as temperature cracks. Sometimes we have spelling of the concrete and reinforcement, especially the structures which are very close to the marine environment. And sometimes we have crushing of the concrete against the lateral loops. In this slide, I'm going to compare the two nations. The first, American, having the rich history of development. He's right now the current superpower of the world. So in America, we have more than 100,000 bridges exist in USA. And more than 40% bridges are classified as a deficient, require rehabilitation as per the Federal Highway authorities. If US governments and different states are going to repair these bridges, they need more than $50 billion per annum. When compared to the Pakistan statistics, we have around 75 years of independence, and we have around 600 bridges during this lifespan of our country. More than 30% of them are reaching towards their design life. Bridge management unit is already developed in National Highway Authority for the monitoring of these structures. And if the government decided to going to rehabilitate, re-strengthen these old bridges, these damaged bridges, it needs more than 17 million rupees dollars per year. Now, what are the problems while we are going to inspect the bridge or the highway? So here are some demerits of the conventional methods. First of all, you have to stop the traffic flow of the bridges. We have to go down, see all around the cracks, patterns around the critical regions of the bridge piers. Unfortunately, in Pakistan, we do not have much good networks, especially I'm talking about the rural areas where if you stop on one path, we have a huge, massive vehicle conjunctions around the bridge, so you cannot do it on regular basis. Also, it's very important. Sometimes you have to go under the bridge pier to see the damages. So these are some demerits of the conventional methods. Now, before going towards the proposed methodology, I would like to highlight the merits and demerits of the current practices. The first one is the visual inspections of these old bridges or infrastructures or buildings. These visual inspections based on the human interpretations. So I'm going to example here that if a person, a structural engineer having an experience of 40 years, the cracks talk about to that senior person in a different manner as compared to if a person like me having 15 years experience or a person, a fresh graduate like you, are going to investigate that problem. So that crack has a different meaning for all of us. And also the problem with the human inspections is that the knowledge transfer is not documented. If I'm saying some argument based on my experience, I cannot justify it. I say, okay, this is my experience. So we do not have a proper documentations for these visual inspections. After that, the researchers, the authorities propose some non-destructive testings. But again, this apparatus has some limitations, like a Smith hammer, the X-rays, and then automated inspections. We have some sensors, and with the help of the drones technology, we can use these things for the inspections. But the problem with the sensors is that they are very costly. They require very less time, but they are very expensive. And developing country like Pakistan, we cannot afford these sensors. So we have the options that how can we use the normal drones and make our own codes and the database for the predictions of these cracks. Now, let's discuss how can we define in a similar manner, in a simple approach about the structural monitoring. So structural monitoring is a process of evaluating the performance of an engineering structure with the help of detecting the localized damage, proposing a suitable techniques as a remedy for the damage. Also, like a human body, I'm again going to give an example of a human body. Is that if a person unfortunately suffering with the cancer and the doctor diagnosed at the early stage, the first or the second stage, the doctors have a good chance to give the good medicines to remedize the problem or disease of the patients. However, if a person came to the doctor at fourth stage, final stage of the cancer, doctor don't have much resources, much time, much options to remedize the problems. In a similar manner, the structure behave. If a structure designer detect the disease of the structure, why the structure is showing this sign of reactions, what are the causes, the authority, the designers can rehabilitate of these structures in a much cheaper way, as less time as compared to when we have a very demolished structure, we cannot rehabilitate that. Normally, the structural monitoring has three levels: the material level, component levels, for example, beam and columns, and the structure levels. But with the time constraint of this seminar, I'm going to only discuss about the material level. So these are some summarize of some different testing as per the ASTM American Standard Testing Methodology codes, materials codes for predicting the compressive strength, the mechanical properties of the concrete and the steel. For example, first of all, we have the destructive testing. We cause some cylinders in the lab, or if we are going to assess the old structure, we have to cut some cores from these structures and conduct the compressive testing on these samples. The disadvantages of this destructive testings are that curing is done in a different environment. Taking concrete course is always costly, damaging the concrete structure being tested. Now, then we have some non-destructive testing, like rebound hammer test, UPV, electric resistance measurements. These apparatus are very costly, and also the results of these apparatus are not as accurate as the destructive testing methods, having the percentage of the plus and 20% liability with respect to the estimated results. For the steel, we can use the GPR methods and the electromagnetic methods. Data collection task is we need a good amount of time to calculate the data and does not work well in a dense rebars area. For example, the tunnels, the retaining walls, and the slabs. To overcome these problems, so now we have issues that the sophisticated apparatus are very costly. We cannot afford them. So that's the one issues. The available methodologies are like taking a lot of time, and their accuracy is not up to the mark. So now we have to a problem where we have to propose a new methodology which is affordable, as well as giving a more accurate results, and also all the interpretation of the results are well documented with the generations of engineers. Now, why we need for this a smart integrated system? So in order to answer all of these questions, which I mentioned right now, we need a smart integrated structure monitoring system. Due to server shortcomings in the existing techniques, interests have gone towards the damage detection technique based on the structure monitoring and the smart integrated structure monitoring system. Recently, with the advancement of the high-performance CPU, GPUs, smart techniques, UAVs, unarmed vehicles, drones, and especially the development in the mathematics of the artificial intelligence and image processing, right now are the attracting domains all around the globe for proposing the solutions of the conventional problems. Now, before going to discuss about research methodology, I'm going to bore you about some basic definitions of the image processing and how it works, image processing, and what is the artificial intelligence. So these 4 and 5 slides are the basics introductions of these two domains, and they are very helpful for the people who are going to think about the artificial intelligence. Especially our final year students can think about how to use this knowledge as to solve their FIP projects. Now, what is image processing? In a simplified manner, if I'm going to define the definition of the image processing, is that you can transform any type of data into a number. If you have a picture, if you have an audio signal, if you have a video signal, you can convert all these things into a pixels, into a numbers, and when you have a numbers, you can perform the mathematical functions. So image processing is a method to perform some operations on image in order to get an enhanced image to extract some information. In digital imaging, a pixel, a picture element, is the smallest item of the information. For example, if I have a picture right here, and I'm going to apply the image processing, so I have some black areas and some white areas. And my pixels have the values from 0 to 255, 0 mean black, and 255 mean the white. Anything between them are the grays element. So in similar manner, we can apply this methodology on the cracks on concrete. And you can see here in figure 16 that after applying the concrete process, we can already highlight the major cracks of the concrete. Now, what is artificial intelligence? What is the subdomain of machine learning? So machine learning is a subfield of artificial intelligence, where the computer learns from a given database. So machine learning has numerous applications. So they are using for face recognitions, speech recognitions, traffic predictions, self-driving cars, detections. For example, all of you have smartphones, and if you are going to search some new topic on your Chrome, which you already searched it in 1 month before, so with the help of your browser history, the Google predicts recommended site for you. Also, if you're going to text a message and you only write the step or you only write MO, so the your computer dictionary, your mobile dictionary will predicting the models work for you. So that's all the small applications of the machine learning. In the last week, we had a gathering in our university, and the people talking about the computer people talking about the humanoid robots around the globe. And okay, right now the computers are working for us, but believe me, within 10 years, you will see a lot of robots around you. Maybe your teacher is a robot teacher. It's not only teaching you is also having some human expressions on their faces. So just imagine a robot is talking to you, but he has expressions of a grief, of a happiness, of a surprise, of a anger, of satisfactions. And this is, I'm not talking about 100 years time. It's believe me, it will going to happen in 10 years. Okay, in Pakistan, we don't have much self-driving car, but we can all saw different videos on YouTube about the self-driving car. So that's how happening. So it's again a humble request to all the faculty members and especially the young engineers. Please opt artificial intelligence. Think about it. Being a civil engineer, you know the basic knowledge of the civil engineer, which is good for you. You know the problems, how you have to identify. But with the help of this AI technique, you're going to propose new methodology. You're going to make your own firms. You are going to create job for the technicians. You are going to make your own world. Believe me, AI is the future. Now, further more about how the AI works. So in 1950s, different mathematicians proposed the functions of the neurons, and they inspire with the function of the human neurons. So that in a manner where the human neuron works, so they try to formulate them and propose a mathematical function for the artificial neuron. So artificial neuron is basically a mimic of the human neurons. So we have millions of neurons in our body, throughout our senses, nervous systems. And if we touch some cold and if we touch some cold and hot water, we feel it immediately in a microseconds due to our due to our this nervous system. So deep learning is a powerful machine algorithm. The fundamental structure of deep learning models is a multi-layer artificial intelligence. You have some input layer, you have some output layer. For example, in input layer, we are going to give a problem to our machine learning that we are going to predict some fruit. First we have to give input as the shape of the fruit as an input, the color of the taste of the fruit, the size of the fruit, and it will predict either it's an apple, it's a grape, orange, or banana. Now, on the same methodology, on the same functions, the ANN is work, the CNN, convolutional neural network, also classified different problems. So they are using for the disease, they are using for the disease recognitions, the tumor disease, the phase recognitions, the disease in the plants, the mechanical parts of the machines. So why not for the civil engineering? And these are some current applications of the AI in the civil engineering. So the developed countries, they are using AI for the offset manufacturing, smart building operations, construction management, sustainability, structure monitoring, structure analysis. So why not we, people from Pakistan, and believe me, whenever I stay in UK for more than 4 years, I visited some European universities, I visit Canada, and I found a lot of Pakistani people there having a lot of great professionals. So if they reach there, so what I believe the generation just viewing this presentation, this seminar, and this seminar, you are more fast than us, believe me. You have all the resources available on Coursera, on Udemy. Okay, I can understand due to some policy making, we cannot include AI subjects in civil engineering, but this is not the excuse for you. So the young guns, you have YouTube access, you have the Udemy free courses, you have the Coursera. Right now, in the last year, when I got this Punjab PTC funding, I got some 2 full-time scholars with me, and they are teaching me about CNN, ANN. So learning has no life, it has no stage. You can learn at any stage, and like people like you have more resources than us. Now, I'm also going to show some literature review about the structure monitoring, and especially the progress respect to the Pakistan research environment. And I also wanted to highlight some gaps. And you know that if you have a gap in certain area, you have a good chance to polish yourself, to make your own word, to make your own name. So in 1910s, the concrete 1910s, after the constructions boom, the cement compositions in 1930s, 20s, there's a boom in 1930s and 40s in the reinforced concrete structures. And when you have concrete structures, also you have to worry about their strength, the supervision problems, their design lives. So in 1930s, the developed countries conducted the structural monitoring on concrete and on steel in 1937. And then they changed visual inspection towards the vibration-based diagnostic system in 1980s, and then some real-time monitoring of bridges and dams in 1980s, excavation monitoring in 1994, landsliding, and tunnel monitoring in 2004, and now is the age of data mining-based structural monitoring. So this is an overview of research trends in image processing concrete structures. It started in 1995 with the help of the morphical analysis, the shear factor measurement, assessment of damage, fire damage, microcracks, compressive strength mortars, deflections, and now estimation of the reinforced concrete compressive strength. So if we compare, if we collect the database from the Science Direct, which is the reliable source of getting the research publications. So in the last 10 years, the Pakistan only published 6 significant or impactful articles which are available on the Scopus and the Science Directs in the field of structural monitoring or reinforced concrete, unlike the India, which published more than 22, and the America have 50. So there's a lot of gap in this area, especially the civil engineers who have the intentions to use AI. Now, what is our proposed methodology for these problems, which I highlighted in the last slides? So we are going to use drones and the power of the GPU for the image processing CNN trains in order to develop a small mobile app. So if you're working in CNW, Pakistan PWD departments, in NHA, in any private sectors, and if you're going to monitor some bridge, the pavements, or the structures, reinforced concrete structures, and you have your own just mobile, you just capture some different pictures with respect to some, the distance, specified distance, and you're going to predict the width, the length, the orientations of these images, especially for those areas where the human cannot go and need a lot of scaffolding, the elevations problems, undersea, above sea issues. So you can use your drones for predicting these things. So we develop a database. We download some database from the Americans universities, and also we created our own database. We divide of 32,000 images. We divided 8,000 images in horizontal cracks, 8,000 vertical cracks, 8,000 diagonal cracks, and 8,000 uncracked images. Remember, these cracks have a similar manner to people from electrical or mechanical domain, but these cracks have different meanings for a civil engineer. For example, if you have a horizontal crack, that means you have a debonding issue between concrete and steel. If you have a vertical crack problem, that means your member is going to fail in a flexure manner. If you have a diagonal crack, that means your member is going to fail in a shear manner. Sometimes you have the vertical cracks converted into the diagonal cracks, or a diagonal cracks converted into the vertical cracks. So you have to be smart in order to identify these cracks. So when you identify these cracks, that will be very helpful you for diagnose the problem of the members, and also it will be very helpful for you in order to propose the remedies for these problems. So after classification of these cracks, another challenge for us to find out the characteristics of these cracks. What is the maximum width of this crack? What is the maximum angle, the changing angle? What is the length of this crack and the crack path? So our current project will give you opportunity to predict the cause of the failure, the extent of the damage, the rehabilitation methodology, and also we are going to embed these algorithms in drones, and we are going to the application phase is right now. We are working on this application phase, and hopefully in a couple of months we are going to give the trial basis. We launch our app for the authorities in order to assess the all bridges or buildings. So this is some statistical informations that we have. As I mentioned, we have had 2,000 images, and we classified in 8,000 classifications in 4 categories. And then we have some 400 images, which is not the part of this set. We just give these images as the testing data set and try to predict the error. So for if I'm going to discuss about the confusion matrix of this testing database, so this is out of 198. So our algorithm predicted 98 accurate diagonal cracks, 96 accurate horizontal cracks, 67 uncracked images, because in uncracked we have some different features of the maintenance issues, and 93% of the vertical cracks. Now, In order to find out the characteristics of the cracks, we took some images from around our campus in Utexla, and we and we mark a scale of 1 feet by 1 feet, and then we measured some cracks as shown in image 1, image 2, image 3 by hand, the angles, the slope, the orientation. So these are real characteristics of the cracks. And then we took some and then we applied some image processing operations on these cracks and find out the width, the crack, the accuracy paths, and these are some results. So our algorithm predicted the angle of 5.81 instead of 6, 16.61 width instead of 20, and 305 100 millimeter length instead of 310. So we have these differences between the measured images and the predicted images for image 1, image 2, and image 3. So in terms of the percentage error, we have more error for the width. The length is, we predicted the length very accurately between the error of 1.5%, but for the width, we have some issues. And why this is the problem? Because the width is not constant along the length of the crack. So that's the challenging phase, and we're still working on this area. The last thing is I'm going to show you a small video that how in a real time you're going to predict the characteristics of the image. Now, in the previous researchers, they only predicted the crack length, where the crack is started and where the crack is end, like as mentioned in the green color, like green line. But you can see the previous researchers' work has some limitations because we do not have that straight cracks in our concrete surfaces. So to overcome this problem, we propose a new methodology, and that methodology is going to measure the actual crack length along the path of the crack, which is highlighted as the yellow line. And you can see that if we are going to measure in the previous 3 images, image 1, image 2, image 3, if we are going to measure end-to-end crack length, so image 1 has 305, however, the actual crack path is 351. Image 2 has 303, however, the actual path is 347. Image 3 has 329, however, the actual path is 376. So if you follow the crack path length, it has more length. Obviously, it is not a straight line. It has some zigzag patterns, and the percentage error is mentioned is around 14%. So combinations of the air and modulus and image processing code will help us to predict the characteristics of cracks, estimation of damage in structures, and give sufficient time to the authorities to take the remedial actions, prediction of the cause of the failure, either it's a shear, flexure, and or combination of both, depending upon the nature of the cracks. So let's see a small video, and then I will take you, I'm going to take your answers and questions. So we move our drone along a small path of the cracks, and you can see as the figure is moving, the slope of the crack is also changing, the slope is changing, the end-to-end length is changing, the width is also changing, and the actual path is also predicting. So the green line, remember, the green line is a straight line end-to-end path, which has smaller length as compared to the actual crack path length. So that's how we predict the characteristics of the cracks on concrete building, bridges, asphalt pavements, with the help of the UAVs, with the help of the power of the CNN convolutional networks. Thank you so much for listening to this recorded lectures. If you have any question, you can also email me at afaq.ahmad@utexla. I'm really thankful once again, the chair of the conference, Dr. Muhammad Shahbaz Sahab. I'm also very thankful for our Federal Minister Planning, Professor Ahsan Iqbal Sahab. I'm also very thankful for the Patterning Chief, Professor Dr. Mansoor Sarwar Sahab. I'm also very thankful to Dr. Tahir, who is the faculty member of the Narowal University, UT Lahore campus, for inviting me for this seminar, helping me about all the resource person. And inshallah, in the next seminar, I will join you physically, and we will have a great discussion about the ANI development. And the last, I want to mention that wherever we have to think about our country. This country gives gives a lot of things to us. Now is our moral duties to pay back to our country, to develop, to propose new methodology where we can attract, where we can solve the problems of our country, and we're going to on a right path. Pakistan Zindabad, Pakistan Zindabad. Thank you so much.